Okay, we're going to do problem 64 from chapter 3. And we need a picture to go with this here. So we have a tennis ball. Notice it's being launched basically in a horizontal direction. So it's not at an angle, it's just horizontally, but obviously above the ground. So if we draw a picture of this situation, we would have the surface of the tennis court here. We've got a net here, okay, that is 0.91 meters above the ground. Then we have the ball being served, and it's roughly double that, a little more. So it's being served with a horizontal velocity, and at the time it's served, it's 2.4 meters up. Okay. And it is 11.9 meters from the net. That's horizontal. Okay. That's part of question A. Then question B is going to get into whether it lands in this range right here. So we're looking for it to land in the service court. Okay. Knowing that, hold on. Knowing that on the other side of the net, this is 6.4 meters away. Let me draw that again. Okay. So these are really two different questions with two sets of givens. And let's write those down separately. So we have in the x direction, we're going to say that it begins at position 0, and that because in the first part they're saying, will the ball be able to basically go over the net, 11.9 meters in front of the server? So as we figure out how to set the givens here, we are going to say, hey, let's say that it's right above or maybe below the net, but at the x position of the net, we want to know how high above the ground it is. And so we're going to set this x position to 11.9 meters, right above or below, or, on top of the net. We know its initial velocity is 22.3 meters per second, all in the x direction because they said horizontal direction. Okay, no angle this time. Acceleration in the x direction is 0. We don't know time that it would take, but we'll find that soon. Okay, y direction. Oops. Well, we know that it starts off at a height of 2.4. We don't know if it crosses the net. That's what we're finding. We're going to say, is it right here? Is it up here? Is it going to hit the net? We don't know. Okay, that's what we're going to find. We do know, because it moves horizontally, its initial velocity in the y direction is 0. Obviously, it's going to have some velocity in the y direction as soon as acceleration gets a chance to deal with it. So here we have negative 9.8, and we don't know time. So that's going to be the first step. So let's find the time that it would take the ball to go 11.9 meters. Since it's launched with this horizontal velocity, we know how long it'll take to cover this x distance if we just solve a simple formula. So here I'm going to take a little shortcut this time and remind you that the horizontal velocity is not changing, and acceleration is 0. So I'm just going to solve for time, and I know that the velocity in the x direction should be the change in x, or the x displacement over change in time. So x at time t minus x0, okay, over change in time. So if I give myself some space here, okay, then this is 22.3. I'm gonna go 11.9 meters from the server, trying to find how long that takes. Okay, so when you do the algebra, it's gonna take less than a second, right? Because it doesn't have to go 22.3. So keeping some sig figs around here, we get 0.534 seconds. So that's great. Now we're gonna find how much it's dropped by then. Because remember, okay, now that we have the time that it will take to go that horizontal distance of 11.9 meters, we're going to see where the tennis ball is at that moment in the y coordinate system. So now let's solve for y at time t. So scroll back down. Okay, here's your formula from your formula card, just with y's instead of x's. And remember, the ball starts off at 2.4 meters above the ground. And then because the velocity in the y direction initially is 0, this whole thing is 0. 0 times time is 0. Plus add on your displacement because of gravity. Okay, hopefully if you do this all on your calculator, you end up with 2.4 meters above the ground, but subtract 1.4 that it falls during that time, and you end up with about a meter. So because a meter is higher than the net, it will clear the net. Okay, so that was part 1, but the second, that were part A. Now part B is asking, will it land in this service court here within 6.4 meters of, the other side of the net? Okay, so that's a different situation now. So this was part A's answer. Okay. So now part B, I'm just going to totally rewrite the givens, which is a little bit overboard, but okay. So part B, x direction, we're still working with the same initial position, but we don't know how far it's going to go beyond the net at the time when it would hit the ground. But we still have this initial conditions. Okay. And so we're going to, in order to solve for where the ball hits the ground, we're going to need to know how much time it takes to hit the ground, which is going to be determined by how long it takes gravity to pull it down from that height that it initially had to begin with. So again, we're starting off at 2.4 above the ground. This time though, we're saying it's going to hit the court. Okay, sorry, let's take one thing at a time here. We still have our Vy0 is 0 and our acceleration in the y direction. So as usual, we're going to find time first. And this time we're using the y equations to help us do that. So we're going to say that okay. So how long is it going to take to get to the ground? Again, this part is 0. Okay. Looks very similar. But this time we're solving for time. Okay. If you do all that algebra, you end up with 0.7 seconds, which is reasonable. Should be less than a second to fall from such a low height. Okay. So that's the first step. And then once we know that, we know displacement in the x, or we're finding displacement in the x direction, and we know velocity in the x direction, and we know time. So find or xt in that amount of time. Okay. And again, I'm going to take a little shortcut here and count on the fact that you know that velocity with a constant velocity, you would get displacement over time. And so we know that velocity is 22.3. We're looking for xt, assuming the initial is 0. And we have a time of 0.7 seconds. So when you solve for xt, you get 16 meters. Now that's from where it was served. So it's going to go the 11.9 to the net. So it's going to go this distance plus another 4.1 to get to 16 meters. So that's definitely 4.1 falls in this range of the service court here. So 16 meters total minus 11.9 before net. Would be 4.1 meters inside service zone. Service court, sorry. So, yes. Okay, we're done.